This is Everything Batteries by FRC 2468. Our presentation today will be split into 5 different sections: safety, health, maintenance, wiring, and charger tricks. Battery safety. Batteries contain many dangerous elements, including lead dioxide, sulfuric acid, and tremendous energy. If the battery breaks, coming in contact with these elements can be a serious health hazard. Many batteries come with MSDS, which stands for Material Safety Data Sheet. The data sheet gives you certain information such as what can hurt you, first aids, fires, spills, handling and storage, and personal protection, etc. This is an example of MSDS. Battery acids coming in contact with the skin, eyes, or lungs can be serious issues. Small leaks in the battery can dry up into crystals and stick to batteries surfaces. If this is the case, we advise washing hands and avoiding contact with eyes at all costs. To prevent accidents, using latex or nitrile gloves when handling battery would be preferred. To avoid contact with the eyes and lungs, wearing safety glasses at all times and moving to a well-ventilated area would keep you safe. We also recommend checking MSDS and talking to teachers and mentors. Our sealed lead acid batteries are made from absorbent glass mat, meaning the battery's sulfuric acid is absorbed by a very fine fiberglass mat. Because the acid is held in the glass mat, AGM batteries are more durable and resistant to vibration, making them safer and more reliable in many applications. Now you must be thinking, what happens if you do spill? Some tools we recommend is a 5-gallon bucket, instructions, and a lot of baking soda, chemical gloves and goggles, and 2-gallon Ziploc bags. While cleaning is important, telling a teacher or mentor and protecting yourself is also very important. Baking soda can neutralize the acid and make it safe to contain the battery and clean up the spill. Allowing peers, teachers, and mentors to be aware of the danger can keep them safe, as they could accidentally expose themselves to the acid or spread it further. It's best to send a student to let your teachers and mentors know of the spill, where it is, how bad it appears, and who is cleaning it up are all questions to consider. In order to protect yourself, it's best to tie your hair back if you have long hair. This way, it will not accidentally touch your hair and transfer to clothing or skin. Inside the spill kit, a personal protective equipment, a PPE, should be there. Putting on your PPE should protect you from contact with the battery, as well as helping to not breathe it in. In order to neutralize the solution, baking soda must be sprinkled over the battery and spilled acid. It's important to focus on any damage or cracks and pooled spillage. When the acid comes in contact with the baking soda, fizz will occur. It is also important to note that more baking soda must be sprinkled on until the fizzing stops. The next step is to carefully place the battery in the 2-gallon Ziploc bag. It helps the cleaning process become a little easier. Adding baking soda into the bag with the leaking battery will help neutralize more of the acid, and then move the battery into the containment vessel. On the spill side, using baking soda to mix and scrape the acid together in order to neutralize anything else. In order to avoid airborne dust, use a brush and a pan to collect the remaining baking soda on the floor and dump into the containment vessel. Try avoiding vacuum, as dust will be thrown in the air and inhaling the dust will not be good. Most likely, the battery acid would stay on your gloves. So if they're reusable, cleaning them would be best before removing them. After cleaning the gloves and washing hands, we strongly advise working in teams to inspect clothes and hair for contamination. If you do come in contact with the battery acid, immediately wash the area with lukewarm water for about 30 minutes. If irritation continues, report immediately to the teachers. Keep in mind, paperwork will likely be needed. Battery basics. There are 5 bullet points a team must go through when getting a new battery. Inspect, wire, test polarity, and finalize. The battery must first be checked that there's no external damage. The battery name, team name, and year acquired are labeled. The battery and the battery leads are crimped together and make sure it's wired to correct terminals. Finally, make sure heat shrinks are in place and the battery is charged and capacity is tested. First, always be mindful of FRC rules and overall safety. Battery labels or printed information should never be written over, and if any required information is obscured, the battery may not be allowed for use. For safety, do not place labels over the vent place on top or terminal side of the battery. The vent plate covers vents that release gases when needed, so covering or sealing this area can damage the battery and create a safety risk.
Moving to battery health is a combination of the battery's capacity, internal resistance, and more. Battery capacity is the amount of energy a battery can store and deliver. So a battery with a higher capacity can store more power for a longer time. A fully discharged battery is not a battery that's outputting a set voltage, but it depends on the discharge current. A higher discharge current will lead to a quicker voltage drop, which can cause brownouts. Brownouts happen when the battery output voltage drops below a set voltage that the circuit needs to run, so components may stop working. As discharge current increases, the measured capacity of the battery will decrease. So a battery discharged at 0.9 amps may measure 18 amp hours, but the same battery discharged at a current of 18 amps may show a capacity of 9.6 amp hours. As discharge current increases, the measured capacity of the battery will decrease. So a battery discharged at 0.9 amps may measure 18 amp hours, but the same battery discharged at a current of 18 amps may show a capacity of 9.6 amp hours. Because of this, FIRST recommends using, or you have to use, an 18 amp hour battery so that you can use your batteries for longer. Ohm's law says that a current I going over a resistance R will cause a voltage drop V. So 100 amps going over a 20 milliohm resistance will cause a voltage drop of 2 volts, making a 12-volt current become a 10-volt current. Internal resistance is the resistance between a battery's terminals and the leads, which are the wires that are connected to the terminals. And although internal resistance is not directly related to the battery, or to the capacity of the battery, a higher internal resistance will lead to a lower measured capacity. So it's important to minimize the amount of resistance with your battery. Everything in a circuit has resistance, including the wires. For example, 4-gauge wire has around 0.2 milliohms per foot, and 6-gauge wire has around 0.4 milliohms per foot. So it's also important to minimize the total length of wires in your circuit to avoid these resistances. Adding to that, as your current draw increases and your internal resistances are constant, that will cause a greater voltage drop. So it's important to make sure that multiple mechanisms don't operate at the same time, because that will cause larger current draw, which will cause a greater voltage drop because of resistance, which can cause brownouts. The healthiest batteries are typically the ones with the highest capacitance and the lowest internal resistances, and it's important to sort them by their capacities and internal resistances. For tournaments, you'll use better ones for qual matches and playoffs, while batteries with lower capacities may be used for practice matches, and practice in general. Like I said, you should categorize your batteries based on their health, so their capacity, and this will help in stressful situations because you will know which batteries you should try and use if you run out. So The West Mountain Radio computerized battery analyzer is one of the many battery testers. The settings are on the screen, and you can come back to the slide afterwards, but you're generally going to want to discharge the battery at whatever the manufacturer recommends, and then set the discharge voltage to whatever the manufacturer also recommends. In this case, for the CBA3, you'd want 100 watts at 7.5 amps, and the CBA5, you'd want 150 watts at 11.25 amps. And then you would record whatever it says the measured capacity is from its desktop application. This Sky RC battery discharger is the one that we recommend, as it's cheaper than the previous one and can operate at higher power dischargers. The settings are also on the slides, and you can refer back to these after the presentation. This is what the graph may look like. You see the voltage on the y-axis and how it decreases as your measured battery capacity increases on the x-axis. You would want batteries further right are better batteries, so those would be the ones that you have put as a good status. You can categorize your batteries by this example. You'd have your team number somewhere on the battery, along with the battery name for identification and the battery status on a sticker with something to indicate what grade it is. A battery beak is a tool made by CTRE. It can measure or estimate internal resistance in the battery and the output voltage, as well as the charge of the battery. What it looks like is on the screen after plugging it into the battery and hitting the green button twice. In the top left, you'll see the charge. On the top right, you'll see the type of battery. On the bottom, you'll see the estimated internal resistance, and in the middle, you'll get 3 voltages. We recommend over 95% charge for matches and less than 30 milliohms or 0.03 ohms. And although it does measure voltage, we find the PDH 2.0 to be more accurate. So if you have one of those, we'd recommend taking those values instead. We'd also recommend recording these values before you use a battery in a match, and then noting how the battery did after the match for future reference and reflection. Moving on to battery maintenance. Some battery maintenance don'ts are to never apply wires or never apply force to the wires. Whether you're unplugging the batteries or carrying them, you should always be carrying batteries by 2 hands on the base, not by the wires. And when you're unplugging them, you want to unplug by the SB connectors, not from the wires. It's also good to avoid deep discharges, as that can hurt battery health and lower their total capacity. Some battery maintenance do's are that they don't like extreme temperatures, so you should try keeping them around room temperature or in cooler rooms. Batteries also like to remain over 50% charged, so whenever it's not season and they're just idle, you should form a charging circuit so that none of them dip too low. Also, always check a battery's charge before using it ever to avoid deep discharges that we talked about on the last slide, and make sure that they don't have high internal resistance or high measured internal resistances. And if they do, then you can try and swap out the leads, as those may be causing the high internal resistance.
Okay, now we're going to move on to actually wiring the battery and using it on the robot. Okay, so whenever wiring a battery, your main goal is to reduce the resistance as much as possible. So the first way you can do this is by keeping your wire length short. Just longer wires have more resistance, so minimizing length while making sure your battery is easy to remove is key. Secondly, as Asher mentioned, you can use 4-gauge wires rather than 6-gauge wires to reduce resistance. And lastly, you want to make sure that the wire that you're using isn't too oxidized. So if you notice your wire is like kind of green and like darkened in the picture, you can make sure to cut it off and strip some new wire before you crimp. And it's also important to keep any other materials you're using clean. Okay. Manufacturers typically provide both regular and tinned copper wires. They provide tinned copper because it reduces the copper's oxidization. However, this is mostly for machines that are going to be used for a long time, like decades. So this is kind of unnecessary for FRC. So we actually recommend to use regular copper over tinned copper because the tinned material can increase resistance. Okay. When actually crimping the battery leads, you want to keep in mind a few tips. First, you should clean the terminal to remove any surface oxide from, like, say, the PDH. You can use an emery cloth to remove oxide. Secondly, you want to make sure the wire isn't oxidized, as I mentioned earlier. So just stripping off anything that's not clean and stripping new wire that's fresh. And make sure when you're crimping to not cut off any of the copper. Okay. This is an example of how you would assemble the battery wires to the battery. So Nordlock washers are washers that just improve the security of the battery leads to the battery. So you want to just use them to in match if your robot is moving around a lot. You don't want your battery to fall out. So that's what these are used for. Similarly, grasshopper knots increase the friction. So many teams use them to improve battery security. Okay. Lastly, polarity test boards can be used to make sure you've connected all your wires correctly. So red to red and black to black. And this is important because whenever running a robot, especially with such a large power source as a battery, if you have incorrectly connected wires, that can create big issues. Next, we're going to move on to battery chargers, which are very important, especially at tournaments, because your battery charger determines how quickly you can charge your batteries. So these are a few examples of battery chargers. And the one that we recommend is the NoCo Genius, mostly because it has the fastest charge rate. So if you ever have emergencies where you need to cycle a new battery in, you can always do that at tournaments. And it also has the ability to adjust currents for different usage purposes. Okay, one thing to keep in mind whenever buying battery chargers and using battery chargers is that they all have to have SB connectors on the end. So some come pre-crimped like the NoCo Genius, but some don't. It's relatively easy to crimp them though, so that's not a big factor when deciding which battery charger to purchase. This is a kit of items you'll need to adapt your battery charger to have an SD connector on the end. And to modify a battery charger's connector, it's relatively simple. You just need to crimp it as you would crimp a battery. So as my teammates explained earlier, you just need to strip some wire and crimp it into some power poles. This is an example of reducing bushings you can use to adapt smaller wire to larger connectors. We use this a lot on our battery beaks and on similar items like that. Okay. These are some of the references we used when making this presentation. And if you would like a copy of this presentation, you can fill out this Google form. Okay, I think that brings us to the end of our meeting. Thank you everyone for watching, and we'll see you next time.